Okay, let us see what we have here. Now, we have two examples here. We are going to see how we have different approaches. So, let us go through this. A particle with a position vector is, so the meaning that they are giving us a position vector. So they are really as to summarize the question. So our R, this one is, they are giving us, let me write them as column form. So 10, 3, then 5. Moves with a constant speed. The moment you hear constant speed, it means that there is no change in velocity. So meaning their acceleration is 0. So the speed they are giving us speed. So our speed is 6 meters per second. The direction of this, so they are giving us direction of this, which is 1, 2, 2. Find the distance already after 6 seconds. So whenever they talk about constant speed, always acceleration is going to be 0 meters per second. Now, you know that now they want us to get the acceleration, the distance. Remember, distance is always the square the magnitude of displacement. So what we get first is our displacement. So from here now, you can see if we have the constant speed there, we can now get, you know that let us start by getting our meters with the constant speed. Let us get our u. Because they are giving us now speed, you know that the velocity, our velocity is always equal to the speed, then times the direction vector, the unit vector of direction vector. So our velocity here we are looking for, we shall get the speed, which is 6, then times d. But how do we get d? Or is our d cap is given by d over magnitude of d. So with this one is going to be d. Our d here is going to be 1, 2, 2. The whole over magnitude of this, the square root of 1 squared, 2 squared plus 2 squared. So our d cap is going to be now 1, 2, 3, and 3. So that is going to be the 1, 2, and this is going to be 4 plus 4, that is 8 plus 1, that is in the square root of that is that. So then our d there is that's going to be now a third into 1, 2, 2. So this is it, it's going to give us 2 into 1, 2, 2. When you simplify by this one, and it's 2. So our velocity there is going to be now 2, 4, 4. Now this is our velocity. Our initial velocity, because the vector is moving at that velocity constant. Okay, so now after that, after getting now our velocity, we know that we need to get so you know that to get find the distance from the origin after those seconds. So that now our r t is always given by then plus s. So can we get s first? Because after getting this displacement, then we shall get the square root. Because this will be the displacement from the origin of this particle. So after getting this, then we can get its magnitude. That would be the distance. So first of all, what is our s? But our s is going to be, we said it's ut plus a half at squared, which will be u, our initial vector, which is there, I mean the initial velocity, which is that. So it's going to be 244 times t. Our t is what? They are giving us time as 5 seconds, then plus a half, 0, then 5 squared. So why are we saying 0? Because of the constant speed. So it's like now our s from here is going to be, this will be 10, this will be 20, then 20, this is going to be our s first there, which we are looking for. So then our rt, say is r then plus s, which is going to be, can we substitute there? Okay, it's going to be our r to the point, which is 10, 3, 5, then plus our s, which is 10, 20, 20. And so our displacement here is going to be 20, 23, then 25. So this is the displacement after 5 seconds. So the displacement after 5 seconds. So then we put after 5 seconds is 20, 25, because our t there is known. So now, to get our distance is going to be magnitude of our 5, which would be now the square root of 20 squared plus 25 squared. And then from here, our distance would be, okay. So here I'm getting 39.4208 meters, and that will be my answer. So always what we have to do, if they ask for the distance, not if they ask for the distance, always get the displacement first, then we get the magnitude of that displacement. That was the technique always. If they give you speed, speed is different from velocity. The same velocity is a vector quantity because it has magnitude and direction, but speed only has magnitude. So if they give you speed to get velocity, get that speed times the direction vector of that. Or if they can give you a vector power to it, that's what you get always. Let us see what happens to this, or I leave it as exercise because it's almost the same here. So now solution here. The initial velocity of the particle moving with a constant acceleration is, so here they are giving us our u is going to be 3, negative 5, this is meters per second. And after 2 seconds, after time t, the velocity of the particle, now here they are giving us speed. The velocity of the particle is 60 meters per second and power to this. So if they give us this, it means that in vectors, this is going to be a scalar because we can't get a direction for this. So meaning that now, to get our velocity here, so they are giving us the speed as 6 meters per second, and then they are giving us the direction vector as 1, 1, this one, parallel. So now we use this and this to get the parallel vector to that. And then they're asking us to get the acceleration. So first of all, to get this final velocity, because after 2 seconds, this is now going to be our final velocity, v. We shall get this times d cap, which will be 6 times the direction vector of this. We get this vector, 1, 1, then under its magnitude, 1 squared plus 1 squared. So this is 1. Okay, this will give us 6, 1, 1. Then this will give us root 2. I think you know how we can rationalize this. Or is our root 2, we can write root 2. So you see that or is 1 over root 2, the same as root 2 over 2. So note this. So if I apply it here, this is going to be, so my b is going to be 6 root 2 over 2 into 1, 1. If I rationalize that, rationalize. But there my vector, if I simplify this, my b is going to be 3 root 2, then 3 root 2. If I multiply this and then I open brackets there. So I have this, I have the time, I have the initial velocity, I have the final velocity, I have the time. How can I get acceleration? Which equation can we use? So that we are going to say b is u plus at. So now we bring in this there up. So now our b is going to be 3 root 2 equaling to our initial, which is 3 negative 5, then plus n into 2. And take these ones this side, shall be added now 3 root 2 minus 3 minus 3 root 2 plus 5 equaling to 2a divided through by 2. Oof. We are going to be having our a as 3 root 2 minus 3 over 2, then 3 root 2 plus 5 all over 2. Now, you can give this as a vector, which will be 3 root 2 minus 3 over 2i, then plus 3 root 2 over 2j meters per second square. So these are meters per second. Meters per second. So as simple as that. So whenever they give you speed, note we convert to velocity by getting that speed times the unit vector of the direction vector we are given. If they don't give you the direction, they will give you a vector parallel to it. If it's a vector parallel to it, they will be telling you that it will be its direction. So how does how we handle that, members? See you in the next lesson.